Okay, so picking up where we left off, we are multiplying rational expressions. To do that, we multiply the numerators and we multiply the denominators. We use laws of exponents to combine, and then of course we simplify. Okay, that's like your most traditional way. That's how a lot of Purple Math Khan Academy, that's how a lot of them do explain how to go about doing this. Okay, my suggestion to you is to be honest. If this one's like example 5, okay, where you just have a monomial divided by another monomial times a monomial divided by another monomial. One term is monomial. When you're doing this, my suggestion to you is just to see what things can cancel, what things can simplify, okay, before you actually multiply through. Because depending on what numbers you're dealing with, they might get really, really big. And then you're stuck there trying to figure out, okay, what number goes into the top and bottom, and it can get kind of crazy. So, like I said, before you multiply, try to simplify. If you look, you got 12 and 4, 5 and 7, okay? Can't 12 simplify with 4? How so? 4 can go into both of these, right? 4 can go into 12 how many times? So basically 12 divided by 4 is 3. What about 4 divided by 4? 1. Okay? Can 5 go into 7, or is there something that 5 and 7 can go into both of those? Nope, other than 1? No. What about x squared on the top and x to the 4th on the bottom? X squared can go into both of these. X squared goes into x squared one time, and then x squared, x to the 4th divided by x squared is what? X squared. So basically I am simplifying first and then multiplying second, okay? In my opinion, like I said, I feel like it's just easier. However, if you don't think so, then you can multiply straight through. It's fine, okay? But now that I'm done, on the top I have 3 times 1 times 5. That's 15. And on the bottom, I have 7 times 1 times x squared, which is, and we're done. So by simplifying first and multiplying second, I don't have to simplify afterwards, okay? And I'm working with smaller numbers prior to that, okay? Examples like 6 and 7. I'm definitely not going to try to multiply that trinomial to that binomial. I'm just going to get something that's super big. But what I am going to do is I'm going to factor my numerators and my denominators, okay? Because if they have common factors, I can cancel those things out, okay? How do I factor x squared plus 2x minus 3? Say again. Do the x, because there's no GCF, right? You always look for GCF first. So there's no GCF. I make my x, what goes on top? Negative 3, what goes on the bottom? 2. What are my two numbers that multiply to give me negative 3, add together to give me 2? 3 and negative 1. So the top of this first fraction turns into x plus 3, x minus 1. What about the bottom? How can I factor that? Take out a 3. 3 is called your what? Greatest common factor. When I take the 3 out, what am I left with? X plus 3. Okay? Don't get excited. Don't start canceling things out just yet. Okay? Can I factor the top of the second fraction? Nope. So I'll leave that how it is. But what about the bottom? Ooh, x minus 2, x minus 1. Okay? Remember, make your x. 2 goes on the top, negative 3 on the bottom. Your two numbers are negative 2 and negative 1. So that's how we got x minus 2, x minus 1. Now, can any common factors cancel out? X minus 1s can cancel out, and x plus 3. The reason why they can cancel out that way is because everything's being multiplied across the board, multiplying across the top, multiplying across the bottom. If I wanted to, I could have written it like this. You don't have to write this. I'm just showing you what I could have written if I wanted to. Okay? That's why all those terms that are common are able to cancel out that way. So what am I left with once I cancel out all the things that are in common? X plus 5 on the top over 3. 3 times x minus 2. And that's our answer. Because I can't go no further than that. Yes? That would not be wrong. That would still be correct. So yes, you could multiply that through and get 3x minus 6. That's fine. So far, multiplication straight? Okay. So if anything, factor, cancel out, multiply. Or if you want to multiply first, then cancel, that's fine too. This one. Can I factor the top? That x squared minus 9x plus 20? Yes. How so? X minus 5, x minus 4. Now, if you're like, how are they getting these numbers so fast? I don't know. Maybe they're going ahead of me. I don't know. But you're looking for two numbers that multiply to give you 20, add together to give you negative 9. That is negative 5 and negative 4. What about the bottom? I take the square root of the 2. This is difference of perfect squares. So that's x minus 5, x plus 5. And that's times x plus 5. Can I write that as a fraction? I want to write that as a fraction. I can just write as x plus 5 over 1. That's essentially what it is. Does anything cancel? X minus 5, x plus 5. So I'm only left with over 1, which is just x minus. Remember, this one is a difference of perfect squares. It's set up in the form of a squared minus b squared, which factors down to a minus b, a plus b. Yeah. So you had x squared minus 25. So those were both perfect squares. Multiplication. You're okay? Okay. Division. When you divide fractions within fractions, you know you multiply by the reciprocal. Same concept here. You're multiplying by the reciprocal of the second fraction, and it is called the multiplicative inverse. But I'm not going to say that. I'm just going to say reciprocal. A common thing you're going to hear me say is KCF, which stands for keep, change, flip. I keep the first fraction, I change the division to multiplication, and then I flip the second fraction. And then it pretty much turns into just like multiplying. Okay? So I'm going to keep, change, flip. So that second fraction gets flipped. That was crucial. That's the most important thing about dividing rational expressions. And then I'm going to simplify. Okay? I don't want to multiply 16 and 20, nor 25 and 8. You could. There's nothing wrong with that. And then simplify from there. How can I simplify anything on the top with anything on the bottom? Is there something that a number can go into both something on the top and the bottom? 8. 8 can go into which one? 16. So 8 goes into 16 twice, and 8 goes into 8 once. Anything else? Okay. 5 goes into 20 how many times? 5 goes into 25? 5 times. And you said something about an x squared? Which x squared? Does it matter? No. It really doesn't. So here we go. If I take out an x squared here, I have to take out an x squared down here. Now, when I take out an x squared, that's going to turn into a what? An x. But I still have an x squared at the top, and an x on the bottom. I can still take out an x. So this turns into 1, but this turns into x. Okay, so I'm going to multiply everything through. I have a 2 times 1 times 4 times x at the top. What does that leave me with? 8x. And along the bottom, I have 5 times 1, which is 5. So 8x over 5. Now, normally I wouldn't write out that multiplication part, that first part in green, but I'm just making sure everyone can see where these numbers are coming from. So remember, when you're dividing, you want to keep, change, flip. I want to keep my first fraction, change that division to multiplication, and then flip my second fraction. From there, we simplify. And we're going to simplify by factoring. I have x squared minus x minus 2. How does that factor? I have x minus 2, x plus 1. If anybody needs to see me do the x, you just let me know, okay? But I'm going to skip it at this point because we've done a lot of factoring already. What about the bottom? How does the bottom factor? I can take out a 2x, and that leaves me with what? X plus 1. Okay, anytime you take out a GCF that is a one whole term, you need to have that 1 as a placeholder. Because if I wanted to distribute it back through, I would need that 1 to make that 2x. Okay, remember, whenever we factor, we always look for the GCF. So we're looking to see what's in common between 2x squared and 2x. So since they both had a 2x in common, we factored that out. And then we basically divided each of those terms by 2x. So that's how we end up with an x plus 1. What about the top of the second fraction? Take a 5 out. That leaves me with what? Always look for GCF. And what about the bottom? Okay, so I heard x minus 7, x plus 3, because you're looking for the two numbers that multiply to give you negative 21, add to give you a negative 4. And my favorite part, I like this because I get to cancel out stuff, and it's like, oh, God, oh, it's nice and neat. Sometimes it won't be nice and neat, but, you know, these are nice. What can I cancel out? X minus 7, x plus 1. Don't ever forget about these constants on the outside. If those can reduce, you want to, but these don't. So I'm left with 5 times x minus 2 on the top, and then 2x times x plus 3 on the bottom. Don't worry, I'm going to give you guys some time to practice on your desk with a couple of these after we do example 10. And now for example 10. I need to keep, change, flip this. Remember, x plus 5 is the same thing as saying x plus 5 over 1. So when I flip it, it's going to become 1 over x plus 5. So keep, change, flip. How do I factor 3x squared plus 3x minus 60? GCF. There's a 3 in common between all of these. Okay? So if I take out a 3, what does that leave me with? Can't I keep factoring that? I got to do my x. X plus 5, x minus 4. So I keep the 3 on the outside, and I have x minus 5, plus 5, x minus 4. That's how you factor the top. Remember, always look for GCF. And then if you can't factor the inside more, you want to do that. How does the bottom factor? I heard -4 and +3. And I can't factor 1, nor can I factor x plus 5. Does anything cancel? X plus 5s? X minus 4s? Ooh, I can cancel my 3's too, right? Good. Because that 3 in the bottom is attached to that x. Wasn't a trick. I was making sure y'all were paying attention. And that's your answer. That is how you multiply and divide rational expressions. Again, my suggestion to you, simplify, either by canceling out common factors or factoring, then canceling out common factors and then multiplying. Okay? So for this last little bit, we are going to add and subtract rational expressions. We're going to add and subtract rational expressions. Okay? So, because these are fractions, just like when you're adding and subtracting, regular fractions, you need to have common denominators. The same concept applies here. You need to have common denominators. After you get your common denominators, from there, then you want to add or subtract across the numerator and keep the common denominator and then simplify. Okay? For this one, you are going to have to do the operation before you can ever simplify. Okay? Because you are adding, not multiplying or subtracting. So, these, pretty simple, right? The denominators are already the same, right? So, when they're the same, then you're good. All you literally have to do is just perform the operation amongst your numerator, and 3 plus 2 is? So, we have 5 over 8x. That is the sum between those two. Like denominators are really nice, okay? Let's look over here at the subtraction. We have like denominators again. So then we just perform that operation amongst our numerator. What's 7 minus 5? 2. So I got 2 over x plus 1. How can this get tricky when it's like denominators? This example right over here. This last example. You have common denominators already. So you just need to perform the operation amongst your numerators. But you are subtracting the second fraction, which means you're subtracting that entire numerator of the second fraction. So you're subtracting x, and you're going to end up subtracting 2. You need to be careful. When it's a binomial or trinomial, when you're subtracting, that negative does get distributed over because you're subtracting that entire second parentheses. Does that make sense? So it will turn into 5x minus 2, which just simplifies down to be what? 4x minus 2. And if you need to, or if you can, you will want to simplify your result after you've added and subtracted. Okay? Does the top factor? If I take out a 2, that gives me 2x minus 1. Does that 2x minus 1 cancel with that x minus 3? No? So then that will be your final answer. If you wanted to write it in the factored form, you can.
Pardon the interruption. Teachers, at this time, please dismiss the boys' tennis team.
I'm just going to let it run.
At this time, please
Unicorn.
Dismiss the boys' tennis team.
Okay. You can leave it as 2 parentheses 2x minus 1 over x minus 3. But if it doesn't cancel, then leaving it like that would suffice. Questions? If they're not like, okay, starting off pretty easy. Okay, they're all monomials on the bottom. Your goal is to get a common denominator. The least common denominator or the lowest common denominator. Okay? So, let's identify what that is first for every single one of these before we start going. My first fraction has a 3x on the bottom. My second fraction has a 9x squared on the bottom. What is the least common denominator? It's not going to be 3. It's going to be what? It's going to be a 9x squared. Okay? Think about it. I need to get the same fraction. Let's take it back to like this and this. Your common denominator is not going to be 3 between 1/3 and 1/9, is it? No, your common denominator is going to be 9. You're going to turn this into what? 3 over 9, so that way you can add it to 1 over 9. Okay? It's the same concept. Okay? The least common denominator doesn't mean like the smallest number. It's the smallest number that both of the denominators can go into. Okay? So 3 can go into 9. 9 can go into 9. And then it's going to be an x squared. Okay? Because the second fraction already has an x squared, so they need to have that in common. Questions on getting that? So, just like when you're adding fractions, once you get your common denominator, you have to adjust the fraction so that it can be that common denominator. 3x times what is going to give me 9x squared, my common denominator? So that means I have to multiply this entire fraction by a 3x. So 3x on top, a 3x on the bottom. What about my second fraction? Do I have to multiply it by anything? No, I don't. So now, this gives me 15x over 9x squared plus 2 over 9x squared. And now I can add them together. So I have my common denominator of 9x squared, and then it just becomes 15x plus 2. I can't simplify that in any way, so then that's my answer. Figure out what that common denominator is, and then you'll be gravy. Okay? What about for B? 14x squared. Think about what number can 7 and 14 both go into, x squared and x can both go into. That's a 14x squared, which means I have to multiply this first fraction by what? Just the 2. So I have to multiply the top and the bottom by 2. Do I have to multiply the second fraction by anything? An x. So then that way it's the same denominator. So then this turns into 2 over 14x squared minus 3x over 14x squared. And now that I have the same denominator, I can't subtract them. That's 2 minus 3x over 14x squared. Looking at the last one. What is the lowest common denominator between 12x and 18x squared? 36x squared. 12 goes into 36 how many times? And 18 goes into 36 how many times? 2. So I have to multiply my first fraction by what? 3x on the top and the bottom. My second fraction by 2. Because I have to get the common denominator. So this turns into 21x over 36x squared plus 10 over 36x squared. With common denominators, I can add them up. Can I simplify the top? So I'm done. Questions here? Get the common denominator. Common denominator. These, when they come to binomials and trinomials, factor first and see what they have in common. All right? Factor the denominators. Can I factor x minus 5? What about 6x minus 30? Not divide. Factor out of 6. That leaves me with an x minus. What is my lowest common denominator between x minus 5 and then 6 times x minus 5? So 6x minus 30 or 6x minus 5. I'm looking for something that both terms can go into. Basically, what's the other one missing? Combine them together. So in order to get that common denominator, what do I have to multiply the first fraction by? Good stuff. Do I have to multiply the second fraction by anything? No. So this just turns into 6. This stays as a 3x. When I add them together, I get a 6 plus 3x over 6x minus 5. Can I factor the top? Factor out of 3. What does that leave me with? 2 plus x over 6x minus 5. Can I simplify that? Sure can. 3 goes into both of these, so then it just becomes 2 plus x over 2x minus 5. And that's my final answer. Okay. What about b? Can I factor either of those denominators? Nope. So then what's going to be my lowest common denominator? So, what? Huh? No, not 2x minus 3. I feel like y'all overthinking it. What's something that both denominators can go into? All right, I'll help you out on this one. Okay? How about 2x minus 1 times x plus 3? I mean, think about it. Doesn't x plus 3 go into 2x minus 1 x plus 3? And doesn't 2x minus 1 go into 2x minus 1 x plus 3? In other words, if they don't have anything in common, you just multiply them by each other. Same thing like 1/5 and 1/9. They don't. They have 45 in common, but you're basically multiplying 9 and 5 together to get 45, right? So that's the whole denominator. Yep. Okay. So this will happen. You might have to multiply by several terms. What am I going to have to multiply this fraction by? 2x minus 1. What am I going to have to multiply the second fraction by? X plus 3 on the top and the bottom. You are going to have to do what with the second fraction? Say again? FOIL. Okay? After this, it becomes some algebra. All right? And these boxes are too small for my handwriting. So this becomes 2x squared minus x all over the common denominator minus x plus 4 times x plus 3. I am going to go ahead and FOIL that out. Thanks. So when you multiply x plus 4 times x plus 3, you get x squared plus 7x plus 12. And now that I have a common denominator, I can take the first numerator and subtract it from the second numerator. So that's going to be 2x squared minus x. I'm showing every step in this tiny little box because I don't want to lose anybody. Remember, because I'm subtracting, I need to keep that second numerator in parentheses because that minus has to distribute to that entire second fraction. Because x times 3 is 3x, 4 times x is 4x, and then you add them together. Yeah, where are you getting a 2 from? Because you're subtracting this entire second fraction. So I'm subtracting x squared, subtracting 7x, subtracting 12. Not just the first term, that entire term. All three of those terms. Does everybody have this written down? Because I got to go to the next page to do the rest. I don't want to be limited in this tiny box. Okay? All right. So if I distribute over that negative, and again, I'm just showing every step because I don't want to lose anybody. Okay? Combining my like terms. What's 2x squared minus x squared? What's negative 1x minus 7x? Then I have a minus 12 here. All of that is over 2x minus 1 and then x plus 3. If I can, I need to simplify. Are there two numbers that multiply to give me negative 12 that add together to give me a negative 8? No? It was close. 6 and 2, but there's no way to get a negative 12 or a negative 8. So since this cannot factor, this is my final answer. Oh, they can get very time consuming. I think we got time to do one more together. So I think I'm going to do that bottom right one. Okay? Mm-mm. All right? Let's look at this bottom one here in D. Okay? If you guys understand D, then you're going to be able to understand C because it's a simpler version. Okay? Start by factoring your denominators. Okay? What two numbers multiply to give you negative 3 that add together to give you a negative 2? Negative 3 and positive 1. What two numbers multiply to give you a negative 12 that add together to give you a positive 1? What is my common denominator between those? Say again. X minus 3. There's more. X plus 1 and x plus 4. That is our common denominator. They already have x minus 3 in common, so I keep that. But because one's missing x plus 1 and the other's missing x plus 4, together all three of those make my common denominator. So again, I'm doing D. I'm just using the C space to answer this. What do I need to multiply the first fraction by so that it's the common denominator? So I need to multiply the top and the bottom by x plus 4. What about the second fraction? X plus 1. So, can I skip this middle step right here of writing them separately and then combine them together? Can I just combine them together? Okay. Is that all right? Like I'm gonna leave out this step right here. I'm just gonna go kind of straight to this step. Okay. So because they have the same denominator at this point, once I've multiplied, I'm going to multiply 2x by an x plus 4. What does that turn into? Plus 8x. And now I'm going to multiply 5 by an x plus 1. 5x plus 5. And because this is a subtraction, I'm subtracting that entire second parenthesis. When I distribute over that negative and combine like terms, what do I get? If I can simplify, I need to simplify. Okay? And it's a great time to review factoring when a is not 1. I need to slide. What's 2 times negative 5? What number is going to go at the bottom? The two numbers are what? 5 and negative 2. So that becomes x plus 5, x minus 2. You slide, divide, and bottoms up. So when I bring this up, this becomes 2x plus 5 and x minus 1. Oh, nope. We were close. It almost canceled out. But because nothing does, if that was an x plus 1, we would need to cancel out those x plus 1s, and then that would be our answer. But because that top is an x minus 1, the bottom is an x plus 1, I cannot go no further than this. And that's my final answer.
So, do you prefer us to leave it in that form, or is it okay to have
the factors? That's fine. You can have the factors.
It doesn't matter which way.
Doesn't matter. As long as that factor form is correct. All right? That is how you add and subtract rational expressions. Okay? That is how you add and subtract rational expressions.